Let us start with the GANs. I'll share my screen. So GANs are adversarial networks. Okay. First of all, we have seen autoencoders. So any one of you can explain what is autoencoder? What does it do?
Ma'am, it tries to give the same output as the input.
Right. Okay. And it has two components.
Encoder and decoder.
Encoder and decoder, right? And the decoder gives output as input of the whole encoder decoder model, that is autoencoder. Okay. So exactly same thing, not exactly, but yeah, GANs are almost similar, have similar architecture as encoders, autoencoders. So we'll see how these work. Secondly, there are basically, let's see, there are many types of generative models. So generative models means they have two components and they are making some representations and generating something like that. So we have two models. First is variational autoencoders and second is GANs. These two are generative models because they are utilizing data which is basically representation, and they are taking input some representation instead of the whole image or whole sample of the data. They are just taking some representations as input. Okay, so there are two models that we are going to discuss. First is variational autoencoders and second is GANs. So their working is different, but they both generate they both trains on the representations, data representation instead of the whole image data set or any other data set. Okay, so there are two types we are going to study today: variational autoencoders and GANs. I'm going into detail for GANs. I'm not getting into much detail for variational autoencoders right now. Okay, so let's see what is the, first of all, we have to see what is the difference between a generative and a discriminative model. So in discriminative model, we have always seen, what do? We have some input data set and we have output class. Suppose we have a cat dog data set. So output class is a cat or a dog. We train on the input features. Features are basically image features. Okay, right? We have done this in CNN. We have done in every other model. Okay, simple classification model like a neural network. We have done this thing. So what we have done is we have a simple input data consisting of set of features X. Okay, and we have from that input features we generate Y, which is a class label whether it's a cat or it's a dog. While discriminative model does not work like that. Okay, so let's see, in a discriminative model, first of all, it tries to learn how to make a realistic representation of some class. Okay, so it takes input some random noise and maybe a class Y and generates a set of features. So this is a different thing. Now what is happening is noise is required because we don't want to generate the same set of features always. So what it is doing is, so see, in a discriminative model we have set of features X and we are training a model and we have output class Y. Okay, while in a generative model we have input noise and it generates set of images. Okay, so these images can be let's say cat or let's say dog. So these images are generated from the noise. Suppose if I am giving the same value, same noise and Y and some input Y, just suppose it is giving one dog image and it is training on this dog image and it wants to generate more similar dog images. So what will happen if we are not adding this noise? What will happen? It will generate the same dog images. Okay, so that is why while training we add some noise. Noise is nothing, just a vector of values 1 2 3 something like that. In while training the second time we will add another noise 4 5 6. Okay, so noises is some random values. So every time we train, so noise is added and input is there, and we want suppose we are giving only noise as input, so it will generate anything. Okay, so we have to tell what kind of image we want as output. Sorry, so we want to tell it that we want a dog image as output, and some we will give some random value so that it will generate a set of dogs. So category of this dog was some this was type 1 dog, it will generate type 2, type 3, type 4 dogs, because some noise is added in the uh, model. Okay, so I hope this point is clear. So generative model generates the y, that is classes, multiple classes. Sorry, it generates the multiple features. So this is feature representation for type 1 class, type 1 dog. This is feature representation for type 2 dog, type 3 dog, and so on. And it takes as input y. Y is the input and x is the output. Over here, x is the input, that is features of multiple classes, and it will multiple classes of dogs. So type 1 dog, type 2 dogs, and so on. So all these features it will take, and it will train on it, and it will tell that okay, this is class 1, class 2, class 3. So it will give classes. So this is the difference between a discriminated and a generative model. So this is explained over here. So in a discriminative model, you have set of images. So whole data set is given as input, and it will tell you, okay, this is a cat, this is another class, this is another class, and this is another class. Okay, so this is input is features, output is y. In generative model, input is classes, that okay, I want to generate a cat type of image, I want to generate a dog type of image, and output is set of features related to that, basically representation, or basically new images which represent similar to cat. So variety of cats I will get as output, variety of dogs I'll get as output. Okay, and noise is added because we don't want same cat to be generated every time model is trained. We want some random cat images to be generated every time model is trained. Okay, so this is a generative model. Now we are going to study two types of generative models today. Okay, instead of GANs, let's see first. So this is the overall architecture of a GAN, but I'll come to this part later on. First, let's see variational autoencoders, and then we will have a look at GAN. Okay, so okay, in a variational autoencoder, what happens is in a variational autoencoder, we have encoder and we have decoder. So autoencoder does is x as input, x dash as output. It wants to generate same input as output. This is autoencoder, right? And it will generate some hidden representation. This is representation. Okay, so this is variational autoencoder. In this is simple autoencoder. In variational autoencoder, one more thing is added, that is noise. Okay, so this is the diagram of simple autoencoder. So how noise is added in this representation? Instead of sampling this, instead of giving this whole representation as input to this decoder over here, what it gives as input to the decoder is a representation, basically some noise. So it generates a probability distribution of all the points over here. If it was having 100 points, so it will generate a probabilistic distribution for all the 100 points. Okay, it will generate a probability, and it will sample some values from this probability distribution, first, second, three, third, and fourth. Some 5 samples it has taken from this distribution, and these samples are given as input to the decoder. So getting what I'm trying to say, I'll repeat it once again. So what they are doing is, in a simple autoencoder, it will generate the representation, and the whole representation, which is a set of values, nothing but a matrix or a vector, and that vector is given as input directly to the decoder. While in variational autoencoder, instead of giving this whole representation as input, it will generate a probability distribution of all these values. So what will happen? Okay, so it will generate a probability distribution, and this probability distribution, the sampling is done for this, and some few data points are given to this. So what will happen is, how this is how we are calling this as a noise, because it is not giving the actual values which is generated from the encoder as input to the decoder, while it is giving some noise, some representation or some noise. So why it is a noise? Because it is not the actual data point, it is the probability distribution, sampling of the probabilities. Now what they are trying to say is, suppose there was value 99 over here, 99 over here. So at value 99 there can be multiple points. So 99 is represented at multiple places, right? So we are not giving the whole set of vector as a correct input to the decoder. We are just giving some random frequencies, basically probability distributions of this as input. So instead of giving the original data, we are giving some random values. Okay, so that is a variational autoencoder. Why this is done is because we want to generate the we just don't want to generate, okay, if it was a cat, we want output as a cat, but we can want some different kinds of cats, category 1, category 2 types of cat. We want to bring variation in the output. Okay, so this is what the overall idea of variational autoencoder is. So okay, if it's not clear, uh, you can ask ki, this is not clear, I'll explain this again. It looks a little bit difficult to understand, but okay, instead of, just only thing to remember is, instead of giving the representation exactly as input, it is giving some noise as input, okay, to bring out the variation in the output. Okay, so this is variation autoencoder. Next is GAN. So let's see the architecture of GAN. So in GAN, what happens is exactly same thing as variational autoencoder. In autoencoders, we have encoder plus decoder. Okay, this is nothing, just a neural network. This is again a neural network, but only the name is different. Similarly, in GAN, there are two neural networks, which is a generator and a discriminator. Generator and a discriminator. Okay, so this is again a neural network and this is again a neural network. Okay, so nothing, only name is changed, and all the neural network, what neural network does is it tries to learn something depending upon what its name is. If it's a encoder, it will learn something. If it's a neural network, it will learn some features. If it's a encoder, it will create some features and so on. Okay, everything is a neural network simply. Okay, now let's see the example. So first of all, let's understand the architecture of GAN. So it has a generator and it has a discriminator. Okay, like we have encoder and we have a decoder in autoencoders or encoder decoder network. Okay, so here we have a generator and we have a discriminator. Now what we do in GAN is a generative adversarial network. We give some random input, that is noise. Step 1, we give a random input, that is any random values, and we want to generate, suppose we have a data set of original paintings. So this was original data set, and with GAN, what we want to do is we want to generate images which exactly looks like these original images. Okay, so this was image 1, image 2, image 3. So we want to generate such images, such original images. So these are the images generated by artists. These were the paintings. Okay, so these were actual paintings. So what we want to do is, we want to, suppose I'm taking an example, suppose we want to generate a set of images or paintings which look exactly like what the artists have already painted. So we want to generate images. Okay, so if I give some random input noise over here to generator, what it will generate? It will generate some random images, right? Some random images. It will have something and something. Okay. Now, what discriminator does is, discriminator is nothing, just a simple classifier. some simple neural network classifier. We have neural network. What it does is it takes set of inputs and it will tell you, okay, this belongs to category of class cat. It belongs to category of class dog, right? So in discriminator is nothing. It's just a classifier. And how the working of discriminator works is it takes input and class 1 and class 2, it gives out the probability. We know this. Suppose it's a cat and it's a dog, so it will say, okay, it is 0 0.8. If you use softmax over here, it will give you zero point 0.8 cat and zero point 0.2 dog. So it will say, okay, the image that was input was cat, right? So exactly same thing is happening over here. Uh, so instead of classifying into a cat or into a dog, what it does is it classifies with whether this image was real or whether this image was fake. So image generated by this discriminator over here will give as will give will be transferred as input to the discriminator, and it this input on this input it will classify whether it's a real or a fake. Real and fake are two classes. So what it wants to do is it will train until it says, okay, 1% probability that it is fake, it is real, and 0 it is fake. So suppose initially what will happen is initially it will be having some values like over here it will be something 0.1, 0.8. Okay, initially when we are training, we have started training, so it will say, okay, the image is fake and this image is fake, this is not a real image, and we want a real image of a painting. So class real says 0.1 probability and fake says 0.8 probability. So image was not real, it was a fake image, and you had to train it again. And for training it, what do we do? Normally in a classifier we back propagate. We update the weights of the network until it reaches to a point where it says, okay, 0.9% it was real and 0.1% it was fake. Okay, so we keep on back propagating for this network, and we keep on training this network until it classifies, it says, okay, this image that was generated was real or a fake. Okay, so this is the role of discriminator. Now how does a discriminator know that this image was fake or this image was real? So it must have some knowledge, some prior knowledge. So for this we give input as real images. So we give those paintings as input over here. Okay, so original paintings we will give as input to the discriminator for training, for learning that, okay, these images were correct, these images were real images, and discriminator will train itself on the real images. And now discriminator know that this type of images are real images and some other type of images are fake images. Okay, so now discriminator knows that. So when this generator generates something, it can tell that it's a real or a fake. Okay, so this point is clear up till here. Any doubts about this? Okay, okay. So I think no questions. So our final goal is to make generator generate the original images. So we will keep on training this whole network until this generator generates the good original images. You know, GANs are very popular, and GANs are able to generate exact same images with a very high accuracy. That is why these are very popular. So these networks are extremely popular because of their high accuracy, and they can generate exact same images which look like the original painting. Some for some painters, which is very, you know, well marked benchmark painters are there, and GANs are able to replicate their paintings. Okay, so GANs are very popular because they are able to uh, generate by so they you over here you can see that generator and discriminator are continuously in talk with each other. So generator is telling, no, you have not learned it correctly. It will then generator will generate something again, and it will give as uh, input to discriminator, then discriminator will say no, you have not reached to a correct output. So this process, so basically this is why they are called adversarial, because each and every both the generator and discriminator are in constant talk with each other. No, that you have not generated the correct image. A discriminator is telling every time generator generates something. Okay, so this is the overall architecture of a GAN. So let's see some examples. So if you have seen, you must have known Ian Goodfellow. He is very popular researcher, and he's basically the father of GANs. So visit his website, visit his blogs on Twitter. So he is Andrew Ng's student. So everybody knows him. Okay, so he has this was developed in 2014, and since 2014 there is a much big too. These images, this images actually does not. They are able to generate such images. They look exactly like they have created some picture of a human being. So see how much progress they have done. So they have generated those images. Earlier they were black and white, then they moved to some blurred and so on. So they are able to create such pictures which actually this person actually doesn't exist. Okay, so they are able to generate such images. So there is a research paper if you want to go through it. So these persons do not exist, and these images are generated from such GANs, from GANs. So they are very popular and extremely uh, efficient, extremely with good accuracy. I mean, they have very high accuracy. Okay, so these are the some cats generated from GANs. But when they generate those images, you can see some images they are just generated randomly, but it's not actually a cat, but GANs are generating them. Okay, based upon whatever input they were having, so they are generating something. So sometimes it happens that it do not get to the real output. So this was a meme, not actually a cat image. So in input, if you have given some meme or which having some, so actually input was this with some meme and some text was written over it. What it has generated is this. So it has tries it basically trying to it is basically trying to replicate the text as well as the image. Replicate whatever is the input in the given in the model. So they are trying to replicate it in a better version. Okay, so this is also not a cat, but it's generating something. Okay, so in image generation, image translation, so this is a video. I've taken this from Andrew Ng's lectures, and it's really good. So you can see that you don't need a zebra to generate how a zebra is moving. You don't need a zebra. You only need a horse. And what they have is they have horse movement, and they have replicated it exactly to zebra. Similarly, left side is a sketch. So from sketch, they are generating actual pictures, actual photographs, actual videos, actual sceneries. So left side is a sketch. They have given this as input, and output is you are getting clouds, you are getting sea, you are getting scenery, just like actual pictures. So GANs are so good. They can do they have very vast applications. From these sketches they can generate sceneries. Okay, so it's very efficient. Next is, so this is the input of a Mona Lisa, the famous painting, and they have tried it to this is the some person who is talking, and they have merged these two. Now it's looking like Mona Lisa is talking. She's already not there. So these are just magic basically. Now next is generation of 3D objects. You can generate furniture, you can generate your home design, anything designing. 3D object generation is possible with the GANs. So GANs is very it has very wide applications, and it's very popular these days. It's every day it's improving itself. Every day it's coming up with a new uh, application. Okay, in animation also it has uh, it has um, done its let's see, visit this, you will find the code for this, and you will find the set of images, this image data set. So you can see first 100 rounds, after 100 rounds of training, it has generated something. Then after 1000 rounds, it's generating something, 2000, 5000, and 10,000 rounds. So now it's generating animes, animated, okay? And at 50,000 rounds it is able to generate expressions as well to those faces. Okay, so it's very very good. In videos there are applications, for example generating the next frame. So you can see the quality of image that is generated by adversarial network. So it's very good. And if you use simple any other neural network, you will get something blurry or something not clear. But if you are using GANs, so it is quality of image is really good. So next frame in the video prediction is it is used for. Okay. Then image to image translation, filling in colors, filling in multiple colors, and converting from aerial view to map view. Okay, so this is also possible, from sketches to actual drawings. Okay, so everything pretty much, it has a very wide applications. uh, Generating this is generated, these images are generated from GANs. So generating a wide variety of rooms and furnitures and so many other things, so many 3D objects. Okay, it's all possible. Then you can see over here, so this man is wearing goggles and a woman face is there. So what they have done is they have merged this woman face with these goggles. So woman plus goggles, and they are improving it at every rounds. You can see finally you get this image. So they have removed this face of the man from this uh, image. So almost anything is possible. You can add, you can predict, you can see how you will look like after 10 years, 12 years, and so on. So many other things. So in almost every big company, it's GANs are used these days. Okay, so let's see how these GANs work. So up till now, if you have any confusion, please ask. Okay, so we have discussed that. Go through it. Okay, I will share a link with you. That is a very good blog. Okay, visit that. You will find uh, there is you will find the explanation for how this works. And if you have any questions, I'm happy to answer. And second thing is, I have used most of this content from the Andrew Ng's lecture. So uh, if you are having access to that, go through it. It will be more clear. Okay. Okay, so let's see how generator and discriminator works. So generator learns basically to make fake, to basically to generate images which looks like actual real images. And discriminator basically distinguishes. It's just a classifier which has two output classes, real and fake, and it says okay, this is a real input image and this is a fake input image. Okay, so discriminator is nothing, it's just a classifier, just tells the generator that okay, no, it is not a real, you have to work more, work hard, work better, keep getting better. So discriminator always keep on giving instructions to generator, keep getting better, and so on. Okay, so once generator learns the good images, once generator say okay, now I have learned the real image, at that time discriminator goes out of picture and it's removed, and the generator is only there left with some weights and some parameters. And now we have generator, now it can generate any real images. Yes, anything. Okay, so discriminator we have discussed. So let's see back propagation. So what happens is, so when I'm giving some random input, so discriminator is basically a classifier. So it's learning, it start learning from the real images, and it's learn from the real images, and it gives some output, that real or fake output. And loss is nothing, just basically cost or a difference between actual and predicted. So it so image input was image, this was a real image, this was some fake image, this was some real image, this was some fake image. Okay, so real, fake, real, fake. So this was the output y, and this was x input. Okay, so this is the data set it is training on. So it is giving some probability, let's say 0 real 0.1, 0.2, and actually we know that it is 100% real and 0% fake. So error is basically what actually it is and what it is learning. So it keeps on learning, it will back propagate, it keeps on learning, then updating the weights, and then forward propagate, backward propagate, forward propagate, backward propagate, and it learns from the real image data set, which has the labels real and fake. Okay, so discriminator is working separately right now. Now when so this is back propagation, the discriminator is basically working separately. Lekin, but there is one more difference, discriminator is also getting input from this generator. So this is okay, we will discuss this part when we are moving on to generator. So input images are basically discriminator is having two types of images. First is actually from the real world, and second is the one that are generated by the generator. For the images that are generated by the generator, sample images that are generated by generator, it will say it is a real or it is a fake depending upon the knowledge that it has learned from this one. Okay, so so it is having, that is why it is having two types of losses. So yes. Okay, so discriminator is having two types of input. It is learning from this type of this input. It is also learning from this input, but it is also informing this one that okay, this is a real image or this is a fake image. It is informing whatever is the loss. It is informing that okay, suppose this has given as image one, this has image two, and for image two, it will inform that okay, no, it is a real and it is a fake image. It may happen that initially discriminator will not be able to tell this correctly because initially discriminator does not know. So as time goes on, it will learn from more real images. So it will keeps on getting better. Discriminator will keep on getting better, and it will keep generator it will also keep on getting better because it is getting output from the. Turn off your microphone, whosoever it is. Okay, so both of these are getting better because as time goes on, discriminator is getting more and more input, and discriminator is also getting input from generator, which is also improving. So initially it will generate extreme fake images, then it will generate some better images, it will generate some more better images, and ultimately it will generate good images, real images. So this generator is also improving. Because of this, discriminator is also. I am video. Oh. Mm. Mm. I don't know. Okay. Don't do such things. It's very difficult topic. Okay. It will not be clear to you. Okay. So I have explained the training part in the discriminator. Now, okay, so this is what is depicted. It's a fake image. It will say, okay, it is some percentage of fake, 0.8 percentage of fake, and it is nothing, just output is nothing, just a softmax layer. How much it is fake, or you can see it is 0.15 real. Okay, simple. Next is generator. Now generator part is basically doing it is more important. Finally we need generator only. in this network, when this generator has learned, this whole part is deleted and removed from the network, and generator will have the weights, actual weights, and it will keep on generating the good images. So at that time it is having final, uh, only generator is required. We only need generator to generate real images when it has learned how to do that. Okay, so let's see generator part. So in generator part, back propagation happens using this discriminator as well, because it is an generator is taking feedback from the discriminator, that whether it's a real or it's a fake. So back propagation in the generator happens this way. Okay, discriminator is also involved while doing back propagation, but in the forward propagation discriminator will not get updated, because we don't want discriminator to change, we want it to have data from this also. Okay, so this discriminator updation is taking place only in this generator part. Okay, let's see. So input is a random noise in the generator. Input is a random noise. Produce the generator output from the sample random noise, right? Correctly, it generates something initially from that noise. Then get discriminator real or fake classification. So discriminator will tell whether it's a real or whether it's a fake. So it calculates loss from the discriminator classification. Discriminator is saying, okay, the image that you have generated was this percent fake and this percent real. So using that loss, it will uh, calculate it back propagate. So it back propagates from here. Okay, it back propagates from this output, and that discriminator is saying it was this percent real or this percent fake, and back propagate to this, and gradients change only for the generator weights. While yes, so while back propagating, this is not changed because it is only telling it generator to change. Discriminator weights are not updated. Why? Because it has the knowledge. It has all knowledge from the real images already. So it is not updated. Only generator is updated right now. So whatever it is telling, generator is updated according to that. And weights are updated, then forward propagate, backward propagate, and so on. This process is repeated. Okay. So this is it. Visit this website. It's a very good website. You will find everything about GAN, basic information about GAN. Okay. So that was it for today. Let's move on to quiz. And before executing the quiz, let me tell you the deep learning components, because everybody is asking how much marks for quiz, how much marks for this and that. Although I have explained this thing, but I will explain this part again. Okay, let me finish it, and after that we'll do for quiz. And in quiz, just remember, I'm telling this again, that there is a negative marking, and in final exams also there's negative marking. So while attempting quiz, do not select some random, do not select all the options randomly. Okay, so select only those options which you feel, only that option which you feel is correct. Otherwise, your marks, you are going to lose marks. Okay, let's discuss about deep learning components. So quiz is 15 marks. Now for quiz, I have explained this earlier also. It has two components, 10 and 5 marks. So for 10 marks, 2.5 into 4 for each module. 2.5, 2.5, 2.5 and 2.5. Module 1 quiz is already done. Module 3 quiz is already done. Module 4 quiz is on Monday, that is Tuesday, next class, that is on 17th November, I think. But whenever is the Tuesday, whenever is your next class. Okay, and this part, for this part you have to, because this consists of CNN, and we have done multiple quizzes on CNN, and midterm exam was also based on that, so you are already well versed with this. So instead of this 2.5, I will give you one short assignment. You have to upload that, and you have enough time. You can do this by I'll show the date. It's by 22nd November. So this is just a short assignment. I will upload this assignment, and you have to, I will give instructions for that as well. Okay, it's just a 2.5 marks assignment, nothing to get much worried about that. Okay. So fourth quiz is on 17 November. I'm repeating this part again. Okay, so these four quizzes are of 10 marks completely, 2.5 plus 2.5 four times. Okay, and this 5 marks is for all the in-class quizzes that we are happening every week. So we are happening up till now. I think we have 9 quizzes, whatever. Okay, so I'll take average of these quizzes. So this is your 5 marks. Okay. Now I hope this quiz question will not arise again because I have answered this. Next is midterm. It is of 15 marks, already done. End term is of 35 marks. Tentative date is 9th December for 2 hours. It will be having negative marking. ठीक है, it will be having some subjective questions as well. Not only objective, it will be having subjective questions. That is why I am giving you this assignment. So I will check this assignment and I will return this to you so that you know how to write and how to express that. ठीक है? So
Ma'am, could you please show the date of the deadline of this assignment? Actually, we have many submissions till 22nd already.
okay, sure. Just let me finish this whole part, then we'll do discussion in the end. Okay, let me finish this complete thing. ठीक है? MTE is 15, end term is 35. Okay. Next is lab. Lab assessment is 10 plus 10. 10 marks for submissions that you have done on LMS, and 10 marks is for the submissions for lab assessment. Some students are not interested in that, so they have lose those marks already. But this week is also lab assessment is going on 9 to 13 November. So by 13 November, hopefully this will be done. Okay, so assessment plus 10 marks for submissions that you have done on the LMS. Okay. Next is project, which is 15 marks. And in deep learning, I'm going to give you maximum marks for the research paper submission. Research paper or report one and the same thing, because exactly content is the same. The only thing that is differs is the format. And tomorrow morning, me and sir is going to discuss about this. You have machine learning class tomorrow morning. So we are going to discuss how to write this. Okay. So you have to submit it by 20th November. Okay. Okay, so this is project. Your evaluation is on 23rd to 27th November, project evaluation, final evaluation, and your research paper submission is 20th November. Okay, you have 10 days to write it. Okay, and in a good format. So we are going to discuss format tomorrow. So keep the deadlines in mind. So 2.5 marks, I'm repeating the whole thing again. 2.5 marks quiz is on 17 November. Two quizzes, module 1 quiz and module 3 quiz is already done. Module 4 quiz is on 17 November, that is on Tuesday. Tuesday, whenever is your deep learning class, Tuesday. Okay, I think it is 17 November. Okay, 2.5 marks assignment deadline we are going to discuss right now. Okay, 2.5 marks assignment you have, I will upload on LMS. You have to submit it over there. Then 15 marks, this is done. MTE is done. End term is 35. Lab is 10 plus 10. 10 for the marks assignment that you upload on LMS, and 10 for the screenshots or whatever you are saying. I'm doing lab assessment. 10 marks are for that. Okay. 15 marks is for project, and maximum marks I will give for research paper. Okay. Out of this 15, maximum weightage is for research paper, and you have to submit it by 20th November. Okay. And 23rd to 27th is your final project evaluation. So write a really good research paper. Even if you are writing minimum pages is 8 pages, even if you are writing 5 pages. Okay, although it is not satisfying the minimum criteria, राइट मतलब आई एम सेइंग कि अगर एक लाइन भी लिखो तो वो लाइन भी खुद से लिखी होनी चाहिए. ऐसा नहीं है यू आर जस्ट कॉपिंग एंड पेस्टिंग इट. वट एवर यू आर अंडरस्टैंडिंग अबाउट दैट, ठीक है, राइट इट इन योर ओन वर्ड्स. एक पैराग्राफ लिखो तो अपने वर्ड्स में लिखो. जस्ट एक सिंपल फंडा है लाइफ में, घास काटो तो अच्छी घास काटो. एक पेपर लिखो, एक लाइन लिखो तो अपने वर्ड्स में लिखो, सिंपल. ठीक है. सो वट एवर यू डू इट होल हार्टेडली. ऐसा नहीं है कॉपी पेस्ट मार दिया इधर उधर से कहीं से. यू आर डाउनलोडिंग समथिंग, यू आर, ठीक है, प्लेगरिज्म नहीं होना चाहिए, जीरो प्लेगरिज्म. मैक्सिमम 5% फ्लैग होता है रिसर्च पेपर में, मैक्सिमम 5% इन अ गुड रिसर्च पेपर. और वो 5% इज ओनली दोज टर्म्स विच आर मतलब बिल्ट इन टर्म, जैसे कि होते हैं न्यूरल नेटवर्क, सिंपल टर्म. ठीक है, इससे ज्यादा फ्लैग नहीं होना चाहिए. और वो ऑटोमेटिकली आ जाएगा इवन इफ यू राइट इट इन योर ओन वर्ड्स. बट इफ यू आर राइटिंग समथिंग, ऐसा हो ही नहीं सकता कि उसमें प्लैग आ जाए. ठीक है, इफ यू आर राइटिंग समथिंग उसमें प्लैग कभी नहीं आएगा. इफ यू आर राइटिंग थिंकिंग, अगर एक न्यूरल नेटवर्क की डेफिनेशन भी है, उसको आप खुद लिख रहे हो, इफ यू आर राइटिंग द डेफिनेशन ऑफ योर न्यूरल नेटवर्क बाय योर सेल्फ, उसमें भी प्लैग नहीं आएगा, because everybody thinks differently. Okay, so that is it from my side. Let's discuss the what you want to say about the deadlines.
मैम जो 9th to 13th नवंबर इवैल्यूएशन, मैम ये क्या है, मतलब कितने मार्क्स का और क्या है?
Yes, because in every week what's happening is I have done 5 lab evaluations till date, so 2 marks each. Fifth evaluation is going on in this week. You must have counted in every alternate lab. I'm taking the screenshots or whatever. ठीक है, so that is each and every is of 2 marks. Each and every lab assessment is of 2 marks, whether you have shared screenshot or whatever. So वो
एक्सक्यूज मी मैम.
मैम आपका आवाज तो था, एक बार प्लीज रिपीट कर सकते हो?
कौन सा वाला रिपीट करना है?
स्क्रीनशॉट वाला.
ओके, सो 10 मार्क्स, देखो 20 मार्क्स इज फॉर लैब, जिसमें से 10 मार्क्स इज फॉर असाइनमेंट दैट यू आर अपलोडिंग ऑन LMS डायरेक्टली, एंड 10 मार्क्स इज फॉर लैब असेसमेंट. लैब असेसमेंट मीन्स whatever you are sharing in the lab timing. You are sharing your screenshot, you are sharing screens, you are discussing your work, anything. Today itself some students have discussed something, so whatever. So 10 marks is for that, and in 5 labs I have taken the lab assessment till date. तो उसके 2 marks हैं for each. 2 marks, 2 into 5 equals to 10. So overall, so 2 marks, 9 to 13 November, last 2 marks.
मैम काफी टाइम से लैब इवैल्यूएशन लाइक हो नहीं रहा है मैम,